Objective 5, Miscellaneous Equations, Part 1. We're going to solve some equations that have imaginary solutions. Consider x squared plus 2x plus 2 equals 0. This does not factor. We're going to use a quadratic formula. Okay, in this case, a is 1, b is 2, c is 2, x equals negative b plus or minus square root b squared minus 4 times a times c over 2a. And in this case, we get negative 2 plus or minus square root 4 minus 8. 4 minus 8 is negative 4 over 2. That's equal to negative 2 plus or minus square root of 4 is 2 and square root of negative 1 is I. And of course we can factor that as 2 minus 1 plus or minus I over 2. And then we just got minus 1 plus or minus I. That's an imaginary solution. These are convenient fictions, fairly useful in mathematics, worth reviewing. That's the first example. Consider following. Suppose we have a function f of x equals x cubed minus 64. We can find the first zero very easy. F of 4 equals 4 cubed minus 64. 64 minus 64, which is 0. So x equals 4 is a 0. Turns out this is a third degree equation. There is something called the fundamental theorem of algebra, and it says an nth degree polynomial has exactly n zeros. Well, this is a third degree polynomial. We only found one. Where's the other two? Well, we can use synthetic division. Divide 4 into 1, 0, 0, negative 64. And bring down the 1. Multiply, add, multiply, add. And 4 times 16 is 64. Add, get 0. And so that gives us an equation, quadratic in nature. Doesn't factor, so we use the quadratic formula. X equals negative b plus or minus square root b squared minus 4 times a times c over 2a. Okay, that's 16 minus 64, square root negative 48 over 2. And we get negative 4 plus or minus. You can break this up into square root of 16, square root of 3, square root of negative 1 over 2. And that's equal to negative 4 plus or minus 4i radical 3 over 2. And you can factor 2 out, or you can divide 2 into both terms, doesn't matter. We get negative 2 plus or minus 2i radical 3. So we have the following result. The zeros are x equals 4 and x equals -2 plus or minus 2i radical 3. There are two, 1 plus, 1 minus. You could take -2 plus 2i radical 3, plug it into f, and you get -2 plus 2i radical 3 cubed minus 64. I'll leave it to your imagination. You could FOIL this, multiply the result by another factor. Guess what? It would equal 64. 64 minus 64 is 0. You can take my word for it. So 3 zeros. Every nth degree polynomial has n zeros. Sometimes it can be repeated, but it will have exactly n zeros. That's all for this. We'll be back with part 2 shortly.